Alright, welcome. This is Math 126, Section 1.4's video, the discussion video. I neglected to put those up very quickly. I think I put them up last night when somebody emailed me. So there's not a lot of questions, but the ones that went up asked for probably all of the questions I figure people would ask. So we're going to go through those. There's a few of them. So we'll see if we can fit it all into one video, but let's dive into it. The first one was number 3. And it says, perform the addition or subtraction, factor out any polynomials if possible. And we have 3 over x minus 2 over x plus 2, and then minus 1 over x plus 2 squared. And I've given myself a lot of room here because I know what's coming. I'm going to have to throw in a bunch of multiplications here. But I want to, in order to add fractions, they all have to have a common denominator, so I need to figure out what that common denominator is. And I have a factor of x here, so my denominator has to have an x. I have a factor of x plus 2, so I also have to have a factor of x plus 2, but I also have to have x plus 2 squared. But that doesn't mean I need an x plus 2 and an x plus 2 squared. This x plus 2 is just repeated over here, so really I just need the x plus 2 squared. This is my lowest common denominator. So I'm going to look at this and say, every single one of these fractions that I'm dealing with, how do I turn that denominator into this denominator? And I'm going to multiply it by what it's missing in the top and the bottom. So the top over here and the bottom over here, the bottom has the x, it's just missing the x plus 2 squared. So I'm going to multiply x plus 2 squared here, and of course in the denominator. Right? Now my denominator is x times x plus 2 squared. Right? And then I have an x plus 2, which means I'm missing an x. I'm going to throw parentheses around here. I'm missing an x, but I'm also missing the other x plus 2. And so I'll multiply that top and bottom. And now at the bottom here, the denominator is x times x plus 2 squared. And that's what I'm going for. This one over here is simply missing the x. So multiply it by x in the numerator and the denominator. I'm going to get rid of this. We know what our LCD is. My denominator should all look like this now. But I'm going to clean this up just a little bit. I'll go step by step through this one. Because essentially what I'm saying then is that I have 3 multiplied by x plus 2 squared in the numerator of this fraction over that x times x plus 2 squared minus 2x times x plus 2 over that x times x plus 2 squared. And never am I going to multiply out the denominators, because if I can simplify stuff, I want to do so as factors, and these are in factored form. So in the very last one, minus x times 1 is just x over x times x plus 2 squared. Right? And now they all have the same denominator. Now I can play with these. Now I can add these together. And so I end up having to either, I can expand these now or expand them later, but in order to simplify it, my numerator is going to end up having to be expanded. If I just try to add it together now, all over the same denominator of x times x plus 2 squared, it's just this thing plus or minus this thing minus this thing, right? So it's just 3 times x plus 2 squared minus 2x times x plus 2 minus x, right? I can't do a whole lot with my numerator up here, right? We can if you wanted to. It's not easy, but you can play around with trying to factor this as it is. Let's not do that because that gets ugly. Instead, I'm going to expand these things out. So let me move this all the way up to the top. So this is 3 times x plus 2 squared minus 2x times x plus 2, and then minus x, and that whole thing, I'm just going to play with this for a minute. I know it's going to end up over this denominator. I'm going to walk away from that for a minute, just play with the numerator so I don't have to play with some big ugly thing. What I want to do though is start with x plus 2 squared. So I'm going to do a little bit of work here. I know my denominator is x times x plus 2 squared. Let's not forget that. But let's get this out of my way. So I want to play with this. I want x plus 2 squared, but x plus 2 squared is x plus 2 times x plus 2, right? And I'll still have this 3 out here, but I'm really just going to FOIL these two together for now. My 3 stays out. It's still on the outside of an x squared plus a 2x plus another 2x and then plus 4. Right? And I can combine 2x and 2x to be 4x. So that's 3 is still out there. That's x squared plus 4x plus 4. And then if I distribute my 3, I'm going to write this up here as my final, not final, but my next step in this process. That gives me 3x squared plus 12x plus 12. That's the expansion of this first term. Right? I'm going to get rid of all of this and expand the next term. In fact, I don't have to do a whole lot. There's no foiling, there's nothing special about the next term. I am going to get rid of this though. 3, 2, 1, here it goes. This negative 2x gets distributed through, so I get a minus 2x squared, and then minus 4x. And then I just have this minus x hanging out there, right? So again, this is all my numerator. All right, numerator, denominator sitting in the corner for a minute, we'll come back to it. But I can clean this up. 3x squared minus 2x squared is just an x squared. Plus 12x minus 4x, that's plus 8x. Oh, I have one more, minus my last x over here, not 8x anymore, but 7x, because I have that, that, and that. And then the 12 hanging out there. And I want to ask myself, could I possibly factor this? Can I get factors of 12 to add up to 7? Right, the factors of 12, 1 and 12, 2 and 6, 3 and 4, I can get a 7, right? And so in factor form, my numerator is x plus 3 multiplied by x plus 4, which the problem asked you to do. It asked you to factor these things. And so I have that. That's my numerator, and then if I plot that over my denominator, it's x plus 2 squared, and that's it. I can't simplify anything because none of my numerator's factors are the same as my denominator's factors. That's just it. I'm done. Are we okay with that? I don't know who I'm asking. That's just a habit. All right. Let's go. That was number 3. So this is definitely going to be in a 2-video sequence, I'm sure, but let's keep going. All right. The next one we're looking at is 14. So 14 says, perform the multiplication and or division and then completely simplify. So we're left with this, or we're starting with this, sorry. X plus 3 over 25x squared minus 9. That gets divided by x squared plus x minus 6 over 5x squared plus 2x minus 3. Alright, whenever I have a fraction being divided by another fraction, the very first thing I want to do is flip that second fraction. So this becomes x plus 3 over 25x squared minus 9. That stays, the left one stays, it's the right one. I'm going to turn it into a multiplication and then flip this. So it's 5x squared plus 2x minus 3 on the numerator, and x squared plus x minus 6 in the denominator. Right? The next thing I want to do is, instead of trying to multiply anything, I want to cancel stuff out if I can. So I want everything factored. X plus 3 is factored. It's just its own little binomial term. So I'll just leave it right there like it is. This 25x squared minus 9, right? Try to recognize that as the difference of two squares. 5x, when that all gets squared, becomes 25x squared, and 3 squared is 9. So this is 5x plus 3 times 5x minus 3. Multiplied by my numerator over here. I have to go through the AC method. 5 times negative 3, right? A times C is negative 15. I don't care about the negative for now. I just want to find factor pairs of 15, and then I'll worry about the negative in a minute. There they are. I want to pick out the one that'll multiply to be negative 15 and add to be positive 2. And there it is. Negative 3, positive 5. And so I have to replace my middle term, right? So recall this. 5x squared, instead of plus 2x, I'm going minus 3x and then plus 5x and then minus 3. Factor what you can out of the first group. I can pull an x out of there, so I get x multiplied by 5x minus 3. There's nothing to pull out of this one, so just pretend like you're pulling out a 1, and you've got a 5x minus 3. And now I've got this 5x minus 3 both here and here. I can pull that out. So this is 5x minus 3, and what's left is this x plus 1. And that's my numerator here. To clean this up a little bit, I'm going to get rid of that work that I just did over there. And I want to factor the denominator over here. This one's easy though, it's just factor pairs of 6. That'll give me 1. That's 3 and negative 2. So that is x plus 3, x minus 2. And then I can hack and slash stuff that appears in the numerator and the denominator both, like this 5x minus 3. There's one in the numerator, on a multiplication, can cancel out one in the denominator. I've got an x plus 3 over here, that'll cancel with an x plus 3 over there. The only thing I'm left with in the numerator is an x plus 1. And my denominator is 5x plus 3 times x minus 2. Okay, and there we are. Okay, good. Let's take a look at another one. Let's look at number 16. Okay, 16 says, perform the addition and or subtraction. This one's not nearly as bad as that number, what was it, 3 that we did? This is 2 over x minus 3 minus 1 over x plus 3. So I need a common denominator, and neither of these are the same. X plus 3 is not the same as x minus 3. So what I'll do is I'll multiply each side by the other. So I get x plus 3, which I then of course have to multiply to the top. And over here I'll multiply this by x minus 3, which of course then I have to multiply to the top, right? So in the top I can distribute 2x plus 6 over my denominator of x plus 3 times x minus 3 minus 1 gets distributed through and it's still just x minus 3 over x plus 3 times x minus 3. Okay. Now I have to be careful with this minus as I combine these into a single fraction. This becomes 2x plus 6. This minus essentially gets distributed through everything here, so it's minus x plus 3. And that's probably the biggest mistake I see on this one, is that stays a minus, but it's a plus. Over my x plus 3 times x minus 3. And then I'll simplify what I can. 2x minus x is just an x. 6 plus 3 is 9, so I have plus 9 over that x plus 3x minus 3. And you can't do anything with that. There's no simplification here, and so we're done. That's our final answer. Which isn't there, as I'm looking at the answers, but if you take x plus 3 times x minus 3, that is x squared minus 9, and that answer is there. So they're equivalent. If you're on a test and you wrote this, I'd be happy with it, I'd be fine. In fact, I'd almost prefer you stopped here. But the computer sometimes wants you to take that one extra step to write it differently, which is good because you need to be able to recognize that these things can be written differently but still be the same thing. So that's 16. How am I doing on time? I'm good. Let me do one more, at least on this video. Let's take a look at 17. Has 1 over x plus 2 over x squared plus 3 over x to the third. Okay. So it should be easy to see that my lowest common denominator is x to the third. I can turn all of these into x to the thirds by multiplying by however many x's they're missing. So x squared in my first one's case, and just an x in the second one's case, and nothing in the third case, right? Now I have x squared times x is x to the third for my denominator for the first, x squared times x is x to the third for the denominator in the fraction of the second, and x to the third of the third. So this then turns into x squared over x to the third plus 2x over x to the third plus 3 over x to the third. They're all x to the third denominators. I can combine this into a single fraction. That is x squared plus 2x plus 3 all over x to the third. And then the only question left is, can I factor that numerator? Yes, I can. That ends up being x plus, oh, just kidding, I can't. So we're done, right? And that answer is there, so we're good. All right, let me look at this next one, 18. I'm going to stop this video here and start a new one for numbers 18, 19, 21, and 22.